A glass of cool water with floating ice cubes is the best drink one can imagine on a hot summer afternoon. But have you ever wondered why ice floats on water? Many of you might already know the simple answer. Water is one of the few substances in nature that expands when it freezes. As a result, frozen water has a lower density than its liquid form, causing the ice to float on top of the water. At first glance, this might not seem like an important issue. But what if I told you this simple fact is what makes life on Earth possible? Let me explain in more detail. Imagine if water, like most other substances, contracted when it froze. This would result in frozen water having a greater density than liquid water. Now think back to the glass of cool water with ice cubes. In this scenario, the ice wouldn't float. Due to its greater density, it would sink to the bottom of the glass. On a larger scale, this is what would happen in winter across the world's oceans and lakes. As the water freezes, the ice wouldn't stay on the surface but would sink to the bottom. Over time, more frozen water would sink, and eventually, by the end of the cold season, all the water on Earth would freeze, causing a global ice age. Could life survive on a frozen planet? Certainly, it is impossible. As you can see, a simple physical law that we don't often think about actually makes life on Earth possible. As a student of fluid mechanics, I first encountered this beautiful and subtle concept in the first term of my university studies, in the first pages of a thermodynamics textbook. It had a profound impact on my life. Now let us proceed. I will briefly list more such examples, hoping that paying closer attention to these small facts might increase our awareness of Earth's extraordinary order, which in turn can inspire greater respect for nature and a stronger responsibility to preserve it. The first example, Earth's gravity is perfectly balanced to hold its atmosphere. Have you ever wondered why Earth's atmosphere doesn't drift into space? The reason is Earth's gravity. It keeps the atmosphere in place around the planet with remarkable precision. If Earth's gravity were even slightly weaker, the atmosphere would escape, and Earth would become a dry, airless planet like Mars, where there is no breathable oxygen and no liquid water to sustain life. On the other hand, if Earth's gravity were even slightly stronger, the atmosphere would become thicker, trapping gases like carbon dioxide and methane. Earth would then resemble Venus, where the atmospheric pressure is 90 times that of Earth, and surface temperatures can reach over 450 degrees Celsius, hot enough to melt lead. In its current state, Earth's gravity not only holds the atmosphere, but also maintains a delicate balance of vital gases like oxygen and nitrogen, while lighter gases such as hydrogen and helium gradually escape. This precise balance makes Earth habitable. Now imagine if this force were just a little different. Would we be here today? Of course not. Another example, Earth's atmosphere is perfectly tuned to block harmful cosmic radiation. Earth's atmosphere not only provides oxygen, but also acts as a shield, protecting the planet from deadly cosmic radiation and solar rays. Without this gaseous layer, Earth would be exposed to ultraviolet rays, gamma radiation, and charged solar particles, which could easily wipe out life, just like what happened on Mars. One of the most critical components of this shield is the ozone layer, which absorbs ultraviolet radiation from the sun. Without it, these rays could cause genetic mutations, skin cancer, and the destruction of many life forms. Another sample. Atmospheric pressure on Earth is just right to keep water in liquid form. Explanation. Atmospheric pressure on Earth is caused by the weight of gases in the atmosphere, like nitrogen, oxygen, and argon, which are pulled toward Earth by gravity. These gas molecules are constantly moving and create pressure as they collide with each other. This is what is known as pressure, and its value varies at different altitudes. The value of it at sea level, which is considered as a standard for measurement, is taken as one atmosphere. As we ascend to higher altitudes, the pressure decreases. For instance, at the summit of Mount Everest, the pressure is about 1/3 of the pressure at sea level. This decrease in pressure is due to the lower concentration of gases in the atmosphere and the reduced weight of the atmosphere at that altitude. But the interesting point is that the pressure on Earth is within a range that keeps water in its liquid state. If atmospheric pressure were lower, water wouldn't stay liquid. It would quickly turn into vapor, and life as we know it wouldn't be possible. On Mars, due to its low atmospheric pressure, water can't remain liquid and either freezes or turns to vapor. On Earth, however, the atmospheric pressure allows water to stay liquid at typical temperatures, which is crucial for sustaining life. Reflecting on these seemingly simple laws and phenomena around us can change our perspective on the world. We often take them for granted and pass by without much thought. But when we pause and reflect, we realize how these precise laws make life possible. Even the slightest change in these laws could have a massive impact on our survival. This realization encourages a deeper appreciation for nature and a sense of responsibility to preserve our planet. Even small changes in nature's delicate balance can have irreversible effects on life on Earth. If you enjoy videos like this, search for similar content on YouTube and don't waste your time and money on worthless videos. Also, make sure to follow my channel as well.